Hello, welcome back. So, to recap, so far we have created a to-do list application in C as a web server. So we have this pretty awesome UI, just a simple UI, which lists the to-do list items and a simple form to add to-dos. We have the APIs completed. We have a simple file-based database to store everything, and most of the coding part is done. Now the next part is packaging and deploy it in a live server. So I took the liberty to make some changes to the code already. So if you remember from some of my earlier videos, I've used a Nix flag to be able to declare my development environment in a declarative way so that it's easy to reproduce. So another nice thing about Nix is that I can also package this in this using a Nix derivation. Also, Nix allows me to build a Docker image out of it without using a Docker file. This is pretty neat because this way everybody who have access to the repository can easily reproduce what I'm doing here without worrying about all the dependencies and such. So without going into much details, I will briefly explain what I've done here. So here, as you can see, I've defined some variables. So I'm going to package this as a Docker container and publish it to my GitHub container registry in my own account. So this will be the name of the Docker image, and so here I've defined the derivation to build the package. So basically it only requires clang and cjson as the dependencies, and in the build phase it just run make. So this is how it builds the application, and in the install phase, whenever we are ready to install it in a different system, so it's going to create this bin directory in the output folder and then copy the built web server binary there, and don't forget to give it executable permission. And we also need the templates because it's a separate file, it's not embedded into the binary. And the next thing is creating this Docker image. So Nix provides us with a really nice tool called build layered image. So this will create a OCI specific, OCI compliant Docker image without using a Docker daemon itself, which is pretty neat. So this will create the manifest and create a tar file which will contain the image itself. So we can use build layer image or build image. There's another method which does not create this many layers, so if you don't want it to be spread across multiple layers. And in the config I just provide this as a command. So when I use this variable here, it will automatically add the binary into the image and make it available. And I set the working directory as this because we would also need to have access to the templates which is inside the same place, and then specify the exposed ports here. This will be part of the image. Okay, so once we have that, what we can do is if we do a Nix build, it will build this default package. So this derivation will be executed and it will build the package. So once we do that, we will get something called a result. So if you check what's inside the result, you can see it has the bin and the template. And if you go here and execute, you can stop the server. You can see that it has a web server, and if I execute it, it runs the same way. And you can also see that the templates have the index.html. So don't forget that we need to add this result into gitignore. Okay, all good. Now let's test the Docker image itself. So to build the Docker image, I need to do nix build Docker. So this will build this part, and as you can see it has completed, and again it's going to be in the result file. This time it's going to be the result. This file is going to contain the entire image itself. So what we can do is docker load this result into the Docker daemon. We can also do like podman load or whatever. So as you can see, this has loaded the image, and you see it's only like 40 kilobytes of layers. Okay, so it has loaded this image with this name because we provided the name here. Okay, and then we can test it. Docker run. I'm gonna do this. So okay, it's working. If I do a docker ps, I can see that it's running, and if I inspect it, I can see some details here. So here is the working directory which is going to be inside the Nix store. This is the command which runs the web server. The interesting part is the IP address. So since I did not expose it to the host, I will have to use the IP address here, and the port number 10,000. So as you can see, it's now running inside the Docker container, which is pretty neat. Okay, so we have the Docker image now, and in order to push it to the GitHub container registry, okay, I'll have to stop this now. So in order to push it to the GitHub registry, instead of doing it manually, I've decided to write a simple GitHub action workflow for this. So I've already done it for a different open source project I have, so I'm just gonna copy it from there. So let me copy it and then explain what it does. GitHub workflows ci.yaml. So this will build the Docker image using Nix and push it to GitHub container registry. So in the build phase, it's going to install Nix, install some cache, so this will make it really fast in the next time, and then it does the Nix build. So the name of the service will be to-do list service. Okay, then it does a Docker login to the repository, the GitHub repository, and for the load and push, so this will do Docker load with the result just like we did before, then pushes the latest image into the GitHub container registry. Okay, then it does something else. So it also tags this with the current date. So this is something I've used to have some automation to automatically update to the latest image, etc. I don't think it's relevant here, but I will just keep it for simplicity. So I'll have to rename the package name. So instead of shopping list, this will be to-do list. Okay, then it will tag it to the new tag and also push it. So this will push two artifacts, the same artifact with two different tags, one with the latest and one with the current date. Okay, so I hope it works. So before we push this, I need to make sure that I have everything ready. So environments, actions. So in the action settings, I need to make sure that it has the read and write permission to be able to push it to the container registry. Okay. Oh wait, this is a shopping list server, so I need to go to Todo List Web C settings, actions, general, read and write permission. Okay, looking good. Did I miss anything? Let me think for a second. I think that's pretty much it. Let's commit and push and see if it works. Okay, so perfect. Docker image build. Okay, if everything goes well, it should start building. And here you can see that it already started building, which is pretty nice. So first it's doing some checks and then starts the build. So it's building the Docker image. As you can see, it's using some Magic Nix cache. So it's going to cache all the dependencies in this local cache, and so from the next time the build is going to be really fast. I'm wondering if the cache is shared across all the packages in the same account, because as you can see it has got a lot of things from the cache already. Yeah, probably that's the case. Okay, so it's looking good so far. It looks like it's pushing. So the login has succeeded, and it has been able to push to the GitHub container registry, and you can see it here in the packages. So the to-do list web C package has been pushed, and here you can see this is the one which we just pushed, and it's also available as the latest one. So we can just pull this and run it anywhere if you want to give it a try. And to deploy this, I'm deploying it in my Kubernetes cluster. So I have a cluster running here, and I already created a namespace called to-do list. So I need to prepare the manifests for this application to be able to deploy it here. And once again, I'm going to refer to our beloved shopping list server. So here we have the manifest already created, so I'm just gonna copy them. Okay. So let's create a folder in Kubernetes and deploy.yaml. Okay, so this will define a deployment in Kubernetes. So we'll replace the shopping list with to-do list. So to-do list label, okay, container name is fine. This is so the name is going to be to-do list web C. Okay, and let's use the latest tag here. So we don't need the environment variable. Resources, not resource hungry application, so let's give it like a 20 megabyte and limited to 50 megabytes. I think that's more than enough for this application. So we have the deployment. We also need a service to expose the server, service.yaml, and change the port number 10,000. Okay, and also an ingress. So I already have an ingress controller, certificate, all those things ready, so why don't we make use of it. To-do list ingress. Okay, leave the annotations as before. Actually, we don't care about the proxy size. Host to-do list cosmos.com. So this is going to resolve to my Kubernetes address for the ingress controller. So this is like 192.168 something, which is running in my local network. So there is no issue in exposing that. And the port number is going to be 10,000. Okay, so this will also make sure to add a HTTPS certificate using Cert Manager. All good. Now we need a customization to combine everything together. I have a separate Flex CD repository to do some automations and stuff, but for now we'll just deploy it from here directly for the purposes of this demo. And in the customization, pretty simple. It will just combine the deployment, service, and ingress into a single file and deploy it in the to-do list namespace. Okay, let's go to Kubernetes folder, customization build. So this will build everything and give us a single YAML file. Just do a quick verification, everything looks good. Okay, and then customization build and apply. So KAF stands for Kubernetes apply -f, it's just an alias. Let's wait for it to be created, and as you can see it's now running. We can check the logs here, nothing yet, that's interesting. And I wonder why is there no logs. Anyway, let's check the ingress. We have the ingress ready. Nope, still waiting for the address to be available. Service is ready. Okay, and what about certificates? Certificates are ready. Okay, ingress is also ready. Let's hope it works. And voila, so we have the to-do list deployed in the Kubernetes cluster. Perfect. Deploy in KAS. I just remember that we don't have a way to mark this as done, but not a big deal at the moment. To-do list complete. Awesome. So we can great. So since this is a file local to the container, now if we restart the container, we are going to lose everything. But that's pretty easy to fix by just having a volume to keep this file. Something we can do in Kubernetes itself. So I'm gonna stop the video here. So we have the application pretty much complete. Now it's working fine and deployed in a cluster. So we have created a web server from scratch without using any libraries except for JSON, which was a decision we made. So let's have a look how much memory it is using. Oh wow, look at that, it's using like 0 megabytes of CPU, 0 megabytes of memory and 0 CPU. That's as lightweight you can get. So maybe as a bit of an experiment, I will try to have some more features like maybe have the database moved to an external volume to have it shared across multiple containers, and maybe have like multiple instances of this running. So for that we definitely need the database file to be outside the container, and maybe also add some like multi-threaded capabilities. So if you remember we are handling everything in a single thread. That means when there are multiple requests concurrently, it won't be able to handle it. So that's something we can add as an improvement later. We can do like a stress test and see how much. I would like to see it use like hundreds of megabytes and handle maybe millions of requests. That's the scope for another video. So thank you so much for listening. I hope it has been a great journey so far. See you soon.